we usually start this course with this lecture on middleware, which is a lecture that has a twofold objective. On one hand, it's a lecture that wants to provide you some information about the context where what we are going to study in this course, or services, web services, service-oriented architectures, takes place. And as we said in the presentation of the course, these kind of technologies, of these kind of approaches, are not revolutionary, they are evolutionary. So there is a long history of well-established practice that are behind this one. And we would like to provide you the context of this one. That's the first objective. The second objective is also a way to kind of break the ice and start to align with probably your different backgrounds and knowledge in computer science. And so it's a way in which we will start to kind of talk this kind of jargon, which is a kind of jargon, it's kind of language, so terminology that are going to be used throughout the courses. So it is respect to other lectures that we are going to have a kind of historical lectures. It's going to be not focused only on a particular topic, but we will give essentially a panorama of some historical panorama on some of the background of these technologies. In particular, we will talk, as it is written there, about the middleware, which plays a very, let's say, fundamental role in service engineering. And it's a little bit denser of concepts because we will touch different topics in different areas typically. The outline is as follows. So first we are going to talk about middleware and its relationship with web services, the goals, and in particular where all this comes from. So about history of middleware and definition of middleware. The second part of the lecture will be more about understanding what are the problems, the main problems that this, let's say, infrastructure is going to help us doing. And we will briefly do an overview. I will touch a couple of them of conventional middleware platforms. I really think that very probably some of these you will not know because they are quite old in the 19th, and some of it you know because they are very popular also today. So we'll start with this one. A brief recall of what the problem is. We said yesterday that the main problem that it's under the umbrella of service design and architecture is the problem of making easier, let's say, or allowing the communication between different stakeholders, different departments within an enterprise, different actors. For instance, the examples that we presented very briefly, you have typically a supplier and someone who wants to supply it. And you have a lot of internal processes, internal services, and you have to make essentially the possibility to allow communication between, in this case, only two actors, but in the real case, in more realistic case, much more actors are involved. And service architecture or service orientation, I will use this terminology, let's say, interchangeably, is a way to solve this problem. And how did we get there? Essentially, we get there as an evolution of architecture of distributed information system. And in order to understand these new architectures or these new approaches, we need to take a step back and look at the middleware as an infrastructure, and in particular at what this middleware, this infrastructure, is doing in this field, which is typically called enterprise application integration, and you will heard about it in this course and probably in other courses. And only with this, we think that then we have the good background and the good context to understand better the current web services. So let me start with something very, very elementary. Basic concepts and notation in software system. Also because, like the little guy over there, you can be maybe at the beginning a little bit puzzled by the various approaches, both in books or by professor or by practitioners that are using for the same concept different kind of words. The main idea here is that the main idea that I want to pass to you, that I need to pass to you, is that in software systems, and in particular, as we will see in distributed system, but not only distributed system, it's very important to have in mind the distinction of a number of, let's say, layers or attention points which are there in every software system. Typically, there is, let's start from the top. You can either start from the top or from the bottom, is immaterial. Let's start from the top. First of all, you have what in the standalone application of software system was typically called presentation layer, which is the layer which is involved to the interaction with the system and with the user. This presentation layer in various different, let's say, software system has also mainly become known as the client. That's what we, both on the web application and on the web service, will call the client. So we have something which is related to the interface with the user, which could be a human or could be, as it is in the case of the web service, just a machine. Then we have another layer which is called in different ways, application logic, business rules, business processes, or just the server, which is where essentially the core part of your application relies. It's the logic of your application. If it is a business application, it's probably the business logic of your application. It's where all the code to enforcing the rules and to coordinate the various activities all the specific knowledge is related. And then we have the bottom layer, we have the data, because it's an information system, and so probably a software system, information system, I will again use these terms interchangeably here. It's dealing with information, and information has to be stored and contained in some kind of data structure. And you have terminology like business objects, persistent storage, database, which is the typical persistent storage, resource manager, database connection. So these are the one of the, let's say, typical segmentations of concerns in software systems. And you will find it in many, I'm pretty sure you have found it in many software development courses, software engineering, and you will find it also here. Why I'm saying I'm starting from this, because there is a kind of game of boxes and arrows that are dealing with these, at least with these three main, let's say, layers. Because for each layer, you can have different, let's say, implementation of these layers, because you have many different databases, different data sources, different components that are dealing with the logic the logic, and maybe different presentation layer for many clients. And it's a good way, this way of introducing layers and boxes to solve a problem of system design, because in some sense you are able to make it simpler, the design, and you are able to divide the concerns that are typical for a particular kind of application. The problem is that each box is a part of the system, as the slide says. Each arrow represents a connection. The more boxes, obviously, the more modular and reusable your system is. The more errors, on the other sense, is the more the system becomes, let's say, less performant, because you have to do a lot of message passing, a lot of context switching every time. So as it is said here, it's very useful, and there is no problem in system design that cannot be solved by adding one level of indirection and adding one of these layers, not, let's say, combining everything into one single piece. It's adding a level of indirection, of abstraction. On the other hand, you have to find that there is some performance issues. As soon as you add a new layer, you have a performance issues because you have to add more modification. So, why this is related to middleware? Let me tell you, take you in a short voyage of information system in the last, I would say, 40 years. Okay, so here we are in the eve of the computing revolution. So, where information systems were starting to be established very strongly in industry. More than in the private houses or in the personal use. It's, let's say, if I have to say a period of time is end of the 60s, all the 70s, and part of the beginning of the 80s, depending where you are in the world. In Italy, for instance, it was mainly in the 70s, where big corporations are starting to heavily use information system. The typical one that you can think of at that time as an clear example is the banking system. So banks were starting to be equipped with information system, and the beginning, the first kind of application were this kind of application, which the first kind of architectures, let's say, was the so-called first tier or one tier application, where the three layers that I told you before were still there, were already there, essentially. It's an old concept, the concept of n-layer architecture, but they were all in one particular machine. So there was this, the typical system was that this institution, banks, insurance company, hospital, every things that you can think of as an example, had a big server. Everything was on the server, and the various users were using the server's services as dumb terminals, or also called thin client. And everything was centralized. There was some good aspects about it. No forced context switches, so very performance. Everything is centralized with the good and bad about it, because if the servers was down, you could not arrive at the right information. And the design was highly optimized to essentially, for the user, you could not really see the difference between these three kind of layers. Now, then the 80s arrived. In the 80s, there is a very big, important, let's say, technological breakthrough or new product that arrives, and it's not very a long time ago, if you think about it. And it's the come of popularity of the PC. So what does it mean in this case? That the terminal from thin client or dumb terminals, the old terminals which had all the little letters in green, are becoming more powerful. And so it's quite, let's say, natural that software development and information system development started to put some more on the client side. And in particular, the first things that goes on the client side is the presentation layer. The presentation layer is, yes, prepared on the server, but is then downloaded to the client and has a specific, let's say, specific features. So you can have, for instance, multiple presentation layers depending on the kind of terminal that you have. You can still, because it's always a problem to maintain compatibility with the past, you can still use the old thin client if you want, but you can have more graphical interfaces, and they start to have graphical user interfaces. It is an important point here. It's an important turning point, because it is at this stage, so quite a long time ago, in the 80s, that by implementing this kind of architecture, the system engineers had to come up with a concept which was new at that time, and now it's very popular, and it's at the basis of the current service architectures, which is the concept of API, which stands for Application Program Interfaces. Why it is that? Because essentially in this system, you have your application, both data and application logics put together, and you want it to be used by different clients. So what you have to do, you have to, from the client point of view, the client has to invoke this kind of interface to be able to connect to the mainframe, to the who is providing the service. And in order to do that, it has to know how to invoke this particular service, query to the database or some kind of functions inside. And therefore, the server has to work with this kind of architecture in which you have everything that it's behind, which is maintained, the data, the application logic, and then a number of resources, and probably with some kind of resource management that provides the service and the service interfaces that goes up. This is quite nice because it's very similar to what we are using today. Obviously, there are some differences, and as we will see through the course what these differences are and how these service APIs have been evolving and has been streamlined and make it more standard. So good, we have two-tier architecture now. It solves some problems. It doesn't solve the problem that we mentioned in the introduction, which is the integration in the enterprises. Well, so what has happened is that there has been a proliferation of various types of servers, one devoted to the one particular, let's say, division, one to some other specific task. Typically in enterprise, you have customer relationship management, and on the other side, you have marketing or sales, accountability, and things like that. And these servers, as we have seen, have both logic and data, while the client is only in a two-tier architecture, focusing only on the presentation. So the integration is still possible, but has to be done at the client level. So the client has to be able to essentially, has to have some application logic because has to talk both with the one server, which has its own logic, its own data, maybe it's a different computer, and with the other. So we still have this problem of, let's say, integration. The first one we talked about, has to combine data from both servers, and it's responsible for everything. So there is very little that can be done to this problem with two-tier approach. The only thing you can do is that you have to write specific wrappers for every server, for every, let's say, silos of information that you want to connect. And this is where there is this rise, that I put here, of an additional level of indirection, which is, as I was telling you before, the typical things that you want to do when you want to solve a problem of integration. You put a layer that is helping you to integrate above. This is where really the concept of middleware, which is now a little bit, let's say, pervasive at the moment, is arriving. And as a first moment, they are starting to talk, and we are here in the middle of the 80s, essentially, of three-layer architectures in which, even if this figure is a little bit misleading, I would like to go probably to the next one directly, because most of these words that are there anyway, I will tell you. It's not that you are taking out all the parts of the application. I mean, it's every individual server and application server providing some services will maintain very probably the authority or the control over its own data and its own logic. What you need is another layer which abstracts from these individual servers and allows a client to access data on the various services. This is a simple concept, and it's a number. It's also very generic because it's not very specific at this moment. I will make you in the next hour essentially some example of this middleware, some of these examples. But what you find here is typically all these services that you give it for granted when you are defining your distributed application. So now we have in mind a very, let's say, popular distributed system, which is the World Wide Web. And what you give for granted is the fact that if you write a program that is capable of sending and receiving HTTP protocol messages, you're able to write your own application. It's clear that your application would not work if there would not be implemented as an infrastructure a kind of system, which is called middleware, that allows your computer and all the computers that are involved during the transmission to process automatically or semi-automatically, most of the time is automatically, these messages and be able to relay it to the final destination, and then when the final destination, which is typically in the web server, is preparing your answer, delivering it back to you. I'm using this example because it's a very well-known example, the web, but it's not the only example, and we will see many other examples of this one, even if I have to say now that it's a very important example, which is taken over all other, let's say, platforms of things. So once you have, we are at the 3-layer architectures. Once you have 3, you can make 4, 5, 6. You can divide and have a layer devoted to a particular specific, let's say, functionality, which is routing, another one devoted to security, another one devoted to whatever, you name it. And so what nowadays it's typically people really talk about is entire architecture. So you have not too many n, so n is should not be too big, otherwise you are essentially downgrading the performance of your system. I didn't mention the web just for as an example. It is a very important example. So I have a slide also of entire architecture, including the web. It is an important infrastructure. It is the most successful one. And it's very well located, as I just finished to say, in this, let's say, architectural view of entire architecture. In particularly, originally, it was really just another layer, because here you have let's say, the various servers, which are indicated essentially as branches. You have their APIs, which are also called wrappers, and you have the middleware, which essentially allows different clients to call in various ways the servers down in the bottom, and it's also capable normally of managing the processes. So it's not only one-to-one call, but also a list of calls in a particular process, which normally are business processes in enterprises. So the web server, in this view, where is the web server, is just the top layer that is essentially adding a layer of, you know what, HTTP protocol, a common way of locating the resources, so URI, Uniform Resource Identifier, a common language of the messages, which at the beginning is HTML, and nowadays is more XML based or extended HTML. So it's adding these few things, and it allows to any client with a browser to be able to access different, let's say, databases at the end, but different services provided by the various silos. So to wrap up this first part of the lecture, there is the idea that I would like to convey you to give at the end is keep in mind there has been an evolution of information systems from the 60s to nowadays. So here we are already 10 years behind, so I should have something more to add over here. And essentially it goes from monolithic kind of application where everything is bundled together in a single application or information system to slowly some kind of subdivision of concerns. And this is where we are. Essentially, this is kind of the part of this course in which we have the database which are taken care. We have some kind of integration logic which are based on services. We have a number of services that the client devises, being a web application, a web browser, a mobile application, or just a standalone application of a particular vertical domain, can call and consume and mesh. That's the combine. It's a new terminology, is meshing services, which is not smashing, is meshing, putting them together, combining and composing them to build a new application. And I will make a short break here before we move on to a kind of panorama of traditional middleware partners so that we can take a little bit of air of oxygen because this room is very small. And I would say that we can start again in about 10 minutes so that we do not end too long later. Okay? Thank you.